All right, class, today we're going to talk about some applications of what we've learned about sequences. So let's take a look at this problem. Jennifer borrows $1,000 and agrees to pay $100 a month plus interest of 1% on the unpaid balance. I want to find the payments for the first 6 months and the remaining debt at the end of that period. So here we have our first payment. Our first payment, that's what our A sub 1 is going to represent. Our first payment is going to be the amount we owe times 1% plus $100. So I'm going to have 10 plus 100, so 110. So that was our first payment. And after we've paid off $100, now we owe $900. 900 times 0.01 plus 100 is going to give me 109. Next, after we've paid off $100, we owe $800. So I take 800 times 0.01 plus 100, and I get 108. Can we kind of see a pattern that's starting to form here? That was for our third month's payment. After our fourth month, fourth month, we pay $700. We have $700 left. So we pay $107 because there's $7 of interest. After our fifth month, we have $600 left. We have 0.01 times 600 plus 100. That's going to be 106. And after our 6th month, we have $500 now. Okay, plus 0.01 plus 100, that equals 105, but we paid off another 100, so the remaining debt at the end of 6 months is going to be $400. I'm sure you guys could have told me that. If I was paying $100 a month on a $1,000 loan and I pay off 6 months worth, 6 times 100 is 600, so I'd have $400 left as my remaining debt. Okay, one more example. Suppose that an automobile loses, this definition actually may be recursive. So suppose that an automobile loses 1/5 of its value each year. That is, at the end of any given year, the value is 4/5 of the value at the beginning of that year. If the car costs $200,000 new, okay, what is the dollar value at the end of 5 years to the nearest dollar? So I'm going to call this A sub 0 because time hasn't started yet. The car is brand spanking new. It's not even a year old. I know that at the end of the first year, my car is going to be worth 4/5 of $2,000, which is $1,600. The same thing happens at the end of year 2, right? At the end of year 2, I'm going to have 4/5 times $1,600. That gives me $12,800. If at the end of 3 years, how many years was I saying? 5. At the end of 3 years, I have 4/5 times 12,800. That equals 10,240. At the end of our 4th year, I have 8,192 left. And one more time, at the end of my 5th year, I have 4/5 times 8,192. That gives me $6,553.60. You can see that this definition is recursive, right? My value the next year depended on the year before. So we can write a recursive definition. I could say that A sub n equals 4/5 times A sub n minus 1. If I wanted to rewrite this as if I wanted to rewrite this in sequence notation.